Hi, this is Mel. Today we're gonna go through chapter summary of Chapter 11. This is Math Method Unit 1 and 2 of VCE subject. Okay, so this one is about random variable, probability, and binomial distribution. Let's go through bit by bit. So what is a random variable? A random variable associates a number with each outcome of a random experiment. So we can give two examples. One is about a die, rolling a die. So if it has 6 sides, then the outcomes can be 1, 2, 3, 4, 5, 6. And the random variable x is the number rolled. So that's how we associate numbers with outcome. The outcome is a number when we roll a die. And the second example can be if we flip a coin. So coins have 2 sides, the outcomes should be head and tail. So we assign, if it's head, let's say x is equal to 1. If it's tail, then x is equal to 0. So that's how we associate number with the outcome, with the physical outcome. So that's how we define the random variable x. So why is it called random? So before the experiment, before we flip a coin, it can be head or it can be tail. So that's where the random meaning come from. And after we did the experiment, after we first flip a coin, if we get head, then it becomes known. So that's not how we show randomness. So the randomness is shown before we do the experiment, and that's why we call it random experiment. Then a discrete random variable. So a random variable and it's discrete. So discrete means it's not continuous, which is can take only a countable number of values. So for example, if for the die we have 1, 2, 3, 4, 5, 6, and that's not continuous. If it's continuous, it should be all the number from 1 to 6, including 1.1 and all the rational numbers and irrational numbers between them. So discrete means only a countable number of values. Often these values are whole numbers, but not necessary. Then the probability distribution. The probability distribution of a discrete random variable x is a function px is equal to probability when the random variable, the big X, is equal to a specific number. That assigns a probability to each value of x. So the small x represents a single value of the random variable, and the big X represents the random variable we talked about earlier. It can be represented by a rule or table or a graph, and must give probability px for every value x that the random variable can take. So normally, if we're dealing with discrete, we're usually using a table. For example, if we have the big X and px. So for the die, we can have 1 and 2, 6. So many grid over here. And then if it's all the same probability for us to get a random side. So the p x is equal to 1 is equal to x equal to 2, equal to 3, and equal to 4, and equal to 5, equal to 6. So we should have 1/6 for each grid. Yeah, and that's the way how we represent through a table. Okay, let's move on. For any discrete probability distribution, the following two conditions must hold. So that's very important to basic rules about any discrete probability distribution. The first one is each value of px belongs interval 0 and 1. So any probability should be greater than 0 and smaller than 1. Or you can write as this. The second one is the sum of all the values px is equal to 1. So for our rolling a die problem over here, so the sum of all the probability from 1 to 6, so we have 1/6 for each grid, and we have six of them, so the sum should always be 1. The next one, the binomial distribution, arises when counting the number of success in a sample chosen from an infinite population or from a finite population with replacement. So the thing with replacement makes sure that every chance is equal. So let's say, for example, if you have a bunch of pen and there are blue and green, if you say I'll choose the blue pen, if I choose the blue pen, then I'm success. Then the chance of getting a blue pen should be equal. And that makes sure the probability is always the same, which means we have to do a replacement each time after you're drawing a pen from the sample or from the population. In either case, the probability P of success on a single trial remains constant for all trials. So that makes sure our p-value do not change. So the probability getting a blue pen or the probability getting a green pen will never change in every sample when we are taking one pen out of the population. If the experiment consists of a number n of identical trials, and the random variable x is a number of success in the n trial. So x is a number of success in n trial, then we have the probability when x is equal to, for example, if we have total of 10 pens, and if we get a blue pen, is probability random variable equal to, let's say 3. If we get 3 of them out of 10 trials, then we can return it as chosen from 10. If we have 3, then the probability, let's say getting a blue pen, blue is 0.7 to the power of x, where now our x is 3 to the power of 3 times the probability. So this represents the probability of successing, and times our probability of not successing, so getting the green pen instead, is 1 minus 0.7. So this actually uses the rule over here. So sum of all the value of px is equal to 1. So if we are getting a blue pen, the probability is 0.7, then getting a green pen should be 1 minus 0.7, which is 0.3. That's getting a green. And that's getting a blue. And don't forget the power, which is 10 minus 3. That's 7. And you should get something, which is greater than 0 and smaller than 1. Okay, so how do we calculate this thing over here? So we have 10 trials, and we're getting 3 of them to be blue. How are we calculating that exactly? So we have a formula over here, which is in terms of the factorial. So remember, n factorial is equal to n times n minus 1 times n minus 2 until 1. And we have x factorial and n minus x factorial down there. So if your n is not very big, for example, if we have 10, then let's do 3 factorial and then 10 minus 3 factorial. That's actually, we can cancel out this part and the top part. Let's write it more clearly. 3 factorial and 7 factorial. Let's cancel out the 7 factorial. And then it becomes 10 times 9 times 8. And remaining 7 factorials, which is cancelled out with the denominator. And then we have the denominator 3 factorial. And you should get something. Okay, that's how we calculate the 10 trials choose 3 problem. And further, the binomial distribution problem. Yeah, that's a quick summary for today, and it's very important to do some practice. Some of them are very tricky questions in the SAC or exam. Yeah. That's chapter 11. Thanks for listening.